microscopic level, they exist to kill. They travel, they attack, they hide, they even gather together in defense maneuvers. Pathogens are the enemies of every member of the healthcare team. On Pathogens and PPE, we give you the tools you need to fight these threats and win. So sit back, tune in, and let's make these microbes tremble at the sound of your name.
Hey everyone, and welcome back to episode 4 of On Pathogens and PPE Season 2. I am Jill Holdsworth with Infection Prevention, and we are diving into water quality today. Don't go anywhere. We will be right back after a message from our sponsors. And welcome back to episode 4 for the second season of the On Pathogens and PPE podcast. I am Jill Holdsworth with Infection Prevention, and I am here with my co-host, one of my favorite people in the world, Aaron Preston. Aaron, thanks for being with me today.
Hey, Jill. Thanks for having me on episode 4.
Why don't you tell everybody a little bit of history about who you are and where you've been in your professional career, how you got to infection prevention?
Sure. So I am an RN by licensure, which I think a lot of IP say, although I'm happy to see that we're expanding outside just the RN roles. I've been doing infection prevention now for about 8 years, and I actually got really brought in by my quality department, who is like, hey, you look like you know what you're doing with improving things. Let's try you out here, and realize I knew absolutely nothing about infection prevention. And so fortunately, APIC has a roadmap, which they taught me a lot. And then from there, over the past 8 years, I've simply been accruing knowledge by asking questions and then reading and learning from extremely smart people like those who are currently on this call. When it comes to some of the things I specialize in, water systems and water engineering, being one, I have done presentations for the Association for Professionals in Infection Control when it comes to water, both in infections and how water management systems can negate that, as well as in water emergencies, as well as working with researchers such as the very awesome Corey Osted, and how water retention can happen in some of our flexible endoscopes in the SPD departments.
And Aaron failed to mention he was in the first class of Advanced Leadership Certifications in Infection Prevention. So that's just one of the accomplishments he probably forgot to mention, but we're really proud of him for that. All right, on this episode, we are diving into everything water quality. And for this, I invited 2 of the most knowledgeable people in water quality that I know, and I'm so happy to have them here with me. We have Jeff Paquet and Shane Sullivan. Jeff, why don't you get us started and introduce yourself to everybody, for those who don't already know you.
Thanks, Jill. Pleased to be on the episode. I'm Jeffrey Paquet. I'm the CEO of Averta Water Quality Systems. We are focused on providing water quality management services to specifically the Sterile Processing department, and specifically around the ST108 requirements. We helped develop the ST108 standard. We worked for a long time with TIR 34, and my background is actually outside of medical. I come from the aerospace world. I'm an aerospace engineer, and I was a designer, and I've done product development and automotive as well as medical and that type of thing. And I've taken what I've learned about manufacturing and about preventing bad things from happening, and sort of we've applied it to, how do we make SPD's life easier so that things don't go wrong as often? And that's what we do at Verta.
I had no idea you were an aerospace engineer. I can't believe I just learned that about
scientist. You. Yep, it is true.
Awesome. Well, thanks for being here, Jeff. We're happy to have you. And Shane, why don't you go ahead?
Yes, my name is Shane Sullivan. I work for a small company called Nephros. We're focused on best-in-class filtration as an aid in infection control. We were born in the dialysis space. where water quality beyond bacteria and virus extend to endotoxin, and endotoxin being a high point of discussion in the SPD environment for the health and the economics of it. It's a good place for us to add additional value to that process. We also provide filtration for pathogens like Legionella and Pseudomonas and NTM in the healthcare environments. We serve the military and military emergency response with individual water purifiers that have Camelback's name on them. So water quality means a lot to us, and it's a privilege to be here. So thank you so much.
Great. Thank you. Let's start off with a really general question here. And Shane, I'll start with you. When we're talking about sterile processing, why is water quality so important? What's the big deal anyway?
Sure. I think most people don't recognize there's a health and an economic proposition. We've got the health, the patient safety aspect. So we're dealing with the bacteria as well as endotoxin. But we're also talking about the economic impact of both the healthcare acquired infection, the nosocomial infection, as well as the life and the quality of the processing of the equipment, the calcification, the corrosion, the expense of that equipment that, if it's not properly cared for, could lead to unnecessary cost overruns for healthcare providers.
So, Shane, it's really interesting you mentioned endotoxins because I don't think there's a true appreciation for the amount of damage or harm an endotoxin can do. So maybe can you elaborate a little more on those endotoxins?
Sure, absolutely. So in the dialysis space, I'll start there because beyond bacteria and viruses, endotoxin leads to patient inflammation and infection. When we're talking in the SPD environment, we're talking about DNA fragment that you absolutely positively do not want to transfer to a multitude of different patients. So by rinsing that equipment free of endotoxin, we're likely to achieve the best results in the surgical procedure that equipment is being used for.
Absolutely, and I think it interests our listeners. Go ahead and look up K-pros and H-pros, or knee and hip surgeries, and look at articles on endotoxins and how it can actually cause complications in those specific types of implants and surgeries. And I think it really kind of brings in context the importance of that particular thing. Thanks.
So, Jeff, let's jump right into the standards. I think everybody has heard recently over the past year or so about ST108, but let's take a step back and talk a little bit about what we've gone through the past few years and give us a little bit of an update on TIR 34 and the transition to ST108. I know you were really involved in the development of some of these standards.
Right. Well, so TIR 34 was the guideline that SPD was sort of loosely following over the past decade or so, prior to ST108 being released. And a guideline is just that. It's not a requirement. It certainly doesn't carry the weight of a requirement or of a standard. But it was sort of a collection of best practices, and not necessarily a sort of all based in, science and the impact it would have on cost benefit analysis to the practices you would have. So there were a lot of recommendation, a lot of advice about what you should test, where you should test it, how often you should test it, and what the department should look like from a design standpoint for plumbing, what type of water equipment you should have and how should be it designed. And sometimes even the information might be a little bit conflicting. So in 2023, they released a new standard ST108, and it was a number of years long effort to really drive down to one source of truth that had scientific data that could back it up from a cost benefit analysis. It was good advice. So that is sort of it in a nutshell.
I'd imagine, Jeffrey, before this, you had to read each individual IFU to see what type of water requirement was made for that type of machines. And when I look at the sterile processing department, the amount of equipment that currently run off water is just astronomical. And so, Do you have any kind of examples or items where you have very bifurcating or differentiating requirements on maybe water needs for some of this equipment that gets used?
Well, it's sort of interesting because that exists even now in the era of ST108, where the common example is the requirements for conductivity of final rinse water. The industry is moving more and more towards what they call clean steam, and in this case, it's really sort of a marketing thing. But it is generating steam from water that has had certain amount of purification to it, and you can have water that by far meets the ST108 spec for conductivity, but it won't meet the spec for the boilers in your sterilizers. So there's an example even today where you can have some conflict between the IFUs of a device or equipment and the standards that you're trying to abide by.
Can you just explain maybe briefly what is conductivity? Because I think we might hear that term, but I don't know maybe if all of our listeners have a good idea of what that is.
Right. So, simply put, it's the ability of water to conduct electricity. And what it is, it's an indicator of dissolved ions in the water. Dissolved ions do bad things to equipment and instruments in terms of corrosion and attacking coatings and stuff like that. So conductivity is used as an indicator of how much free ions you have in your water that could be represent damaging processes. So if it doesn't conduct electricity, it's good water.
So what would happen if you had high conductivity? What would you start seeing on your instrumentation or your sets or wraps? Would you notice something different if it was really high or off?
So you probably wouldn't see something immediately, but if suddenly you had a spike in conductivity that was maintained for a while, you would begin to see some change in the finish of your instruments. You might see areas where you're getting pitting, discoloration, staining. All these things can be indicators of a conductivity problem.
I feel like this could be a whole podcast episode on its own. People wanting to know, what is this stain? What is this weird look of my instrument?
Good news is if you go into ST108, they have pictures and it'll tell you what might be going on.
This is your sign to get a copy of ST108 if you don't already have it. And I will say the first time I read it was not a quick read. It's definitely something that you have to be ready to read. It's not like bedtime reading. You definitely have to be ready to read it. It took me a couple times to really digest what I was reading. So make sure that you're in a good space with maybe some coffee when you go through it for the first time.
And if you have particularly if you're coming at it with no background in it, I'm not sure you'll really be able to comprehend it until you actually get your hands on some water problems. So.
Yeah, and I will say firsthand for probably me and Aaron that I would say that's true. We understand it much more because we have gone through many things in our careers at this point that have taught us a lot. So hopefully, people listening never have to learn hands-on at all. And their water is always perfect, but that probably won't happen. And the more you learn before you have the water problems, the better you'll be able to handle them when they do come, because there's no prep when these things happen. You either start having weird things happening on your instruments, weird stains, or you have a flood, or there's no water. So things happen when they happen. So Shane, where does water filtration come into this and in all of the water quality ST108? Where does filtration fit in?
Sure. There's so many areas where filtration does come in. Let's take a look at utility water. Utility water is your domestic water for your decontamination area. Within ST108, you have requirements for HBC, your heterotrophic bacteria. These are generalized bacteria. Now, what's important to note is that your city treats that domestic water, and it can enter your building with as much as 500 CFU of heterotrophic bacteria. But when you look at where your SPD department is, where it's located, and the potential for incubation within that building, you may need filtration to maintain a control measure of 500 CFU at the point of use, even for utility water. So utility water is a great first start. It's oftentimes when you're looking at the RO and DI or RO or DI with UV, that you may not have the perfect complement of filtration, and you need to add an additional level of filtration at the point of use. What's unique about ST108 is you have point of generation testing and point of use testing. So by applying an endotoxin filter at point of use, giving yourself the ability to sample point of use, you're likely going to see the best results by implementing these small process improvements that will deliver massively important results.
Just to back up just a second, let's do a couple definitions for some people that may be hearing some of these things for the first time. Let's do a simple one first. Shane, will you just tell everybody listening what utility water is?
Utility water is your domestic water. It is typically untreated water, and it is used in the decontamination. Usually the gross washing and rinsing. It is typically untreated water.
So basically like tap water.
Tap water.
Tap water.
Yes.
Okay. All right. And Jeff, do you want to take the definitions of what's RO, what's DI? Why would you have a combination system?
Sure. So fundamentally, when we talk about RO or DI, we're essentially talking about deionizing water one way or another. They're different processes. The RO is a process that we're sort of familiar with, where maybe in your house you have an RO unit where you have this filter and water is pushed through a filter and it removes stuff in your water. And that's what RO does. And there is somewhat of an electrical component where the membranes are charged, so it will repel microorganisms and some things. But it's generally a filtration process. The thing is, it's fairly proportional. So depending on your water quality, it'll do its job. And however, if you have bad water going in, you'll get better water going out, certainly. But there's a certain amount of proportionality there. But generally, RO for most hospitals is going to be sufficient for meeting requirements for ST108. Deionization is where you're using electrically charged beads that water flows over and it removes ions from the water that way. And you can use either method, and it's sort of a how much are you using and how expensive you want it to be. RO is a big cost up front, but the cost to maintain is lower. DI, because you have to switch out tanks frequently, is very expensive to operate, but not very expensive to get into. And then you might have the two in combo when your RO isn't doing a good enough job to purify the water. You would polish the water with a DI tank, which is what we do for sterilizers that need more purified water than the RO is providing. We will polish that water with the DI tank.
Yeah, I think, Jeff, you bring up a good point. You know, it used to be when I first started, I would think when I look at filtration, I think, well, smaller is better, right? But I have learned since being around and hanging around very, very smart persons such as yourselves, what you're trying to filter kind of matters as much as how you're trying to filter it. So I don't know if Shane or Jeff, you want to kind of maybe go over, you know, the difference. You said deionizing, Jeff, I heard for RO. So if I'm trying to get minerals out, what does that mean?
You want to talk about it from a filtration perspective, Shane?
Sure. My perspective on RO and DI is perhaps a little different. The RO uses a semi-permeable membrane to remove particulate, to remove minerals. It is a reliable barrier for that. When left in remission over a period of time, because it works under high pressure, you have the propensity to actually push through and grow through bacteria. What RO does is generally generates 50% of product water or permeate, and 50% goes to drain. So there's a lot of waste in the RO process. What RO does is concentrate salts and oxygens. So what DI does as a complement is it addresses the concentrated salts and oxygens. So you get a complement with the RO and the DI, because the DI does not use a semi-permeable membrane. It uses no membrane at all. So the two act as a yin and a yang in a perfect complement. Usually a system will also incorporate a UV system. Now, UV is good for clean water, and by the time it goes through RO and DI, it's relatively clean. But what does UV do? It generates endotoxin. So what you've done in that process is you may have addressed the debris, you may have addressed the calcium and the magnesium, you will not address bacteria reliably with those, and that's why the endotoxin filtration as a final barrier, which is also indicative of how dialysis water is treated, is such an important role as a complement.
Yeah, so it sounds like it's, there is probably no one system that rules them all. That really you need to kind of define when you're talking to somebody, you're talking to your facilities, you're talking to a contractor about, well, what are you trying to achieve? What are you trying to achieve with that water?
What's different about AAMI ST108 in a water management program for pathogens like Legionella is you would never test your water for Legionella until you have a water management program, until you have a process in place to address it. Where I've been led to believe that in ST108, they want you to test your water, know what challenges you have ahead of time, and then pivot to address. Like Jeffrey said, an RO may be good in some parts of the country. You may not need DI, but in many parts of the country, you probably need RO and DI and more steps along the way to get you to that level of filtration for that critical water that you can't do with one system alone.
Shane, can you go back and explain what you said about UV generates endotoxins?
So for anything that's living past an RO and DI, because DI fails catastrophically and does not deal with bacteria, let's say that you have living organisms in that water and UV is capable of addressing those living organisms in the water. By killing those organisms, they will create those dead bodies, which is endotoxin. And that endotoxin, as you decontaminate, you'll elevate the level of endotoxin as a general rule. Start with living, address the disinfection, you will generate endotoxin as a result of that. And so having that final barrier, having that point of use endotoxin filtration may be ways that some facilities need to cover all aspects of ST108. And we've seen that in the West Coast in particular.
Yeah, that's really interesting. All right, let's pivot just a little bit and start kind of walking through sterile processing and taking a look at each area. So if I'm an IP or I'm the SPD director and I'm kind of looking at my water quality program and I'm in decon, where am I going to look to see, is my water working as it should? Where am I looking for water or critical water? Where should my eyes be going, or where should I be curious to look? And Jeff, do you want to start there?
Sure. Well, I think the first thing you really need to do when you assess your department is to evaluate, how am I using water now, and am I using it correctly even? You have to look at the IFUs for your instruments and equipment and make sure that you are providing what you think at least is the right type of water. You're using domestic utility water where you're supposed to be using it, and you're using the critical water where you're supposed to be using it. And then the next thing you need to do is determine what type, is the water I'm providing meeting the specification of the things I'm providing it to? And also, is how I'm delivering it designed appropriately so as not to increase the risk of bacterial growth so connecting to stuff and that type of thing is all very important when you begin to look at your department. Do my sinks have these long service loops that come off the critical water and go to my critical faucet? Well, those service loops become a place where bacteria will grow because it'll stagnate. It's not moving around. So those are some of the things that you should look at when you're first beginning to look at the department. How am I using the water? Am I using it properly? And is it the right water? And is it connected right?
And I think I know at least when I've seen like our washer disinfector, one machine does not necessarily get its water from the same source. It can bifurcate in multiple areas, if I recall correct.
Yeah, well, if you're talking about this, like the domestic water, sometimes domestic water is coming into the department from a couple different areas, and it can have different qualities depending on where it's been in the building. So you can't just assume when I test one washer that I'm good to go because I passed the test there, because it may be that your other washer is getting water that's not to spec. It depends on where it's been in the building, how old the building is, and that type of thing. So
it's pretty important to kind of start partnering with your facilities department, who most likely have the drawings, and figuring out what is going where.
Exactly.
And that was actually the thing that I was going to mention. A lot of this may seem very overwhelming when first listening to it. If you're an IP or you're a leader in SPD, you may not have any idea of how to start doing these assessments. And really, none of us are supposed to know how to do all of this if we are starting from ground zero with learning ST108 and water quality. So definitely partner with your facilities department, your water quality vendor, somebody that knows how to walk through this process with you. And I can remember doing this. We called it a reverse risk assessment with a water quality vendor. We went around and we started looking at the pipes and looking at where the water came from. And we created our own risk assessment from that, because we found all of the things that were maybe not optimal. And we started kind of writing those down as questions so that we could go back and re-look at those things in whatever amount of time we wanted to look at them. So this is not meant to be done alone. This is definitely going to be a learning process for a lot of people. Now, this question, I don't know, it may be complicated, may have too big of an answer, but if you're on the clean side, what might you notice on your instrumentation if maybe the water quality is off? What might be a good indicator that you should at least speak up and ask questions? Either one of you can start on this one.
Yeah, certainly your packs, and certainly any type of calcification, corrosion, discoloration on your instruments would be a great indicator. Unfortunately, it's pretty late in the game at that point in time. You've already processed it, right? So by testing your water, your utility water and your critical water, and determining where you're going to sample at the individual pieces of equipment, because that's part of that requirement. There are 8 shalls and 300 shoulds, but the testing is required. I think you're going to get a pretty good indication of what you need to do to avoid those types of challenges. So again, once you see it, kind of too late, and you're having to backtrack. So getting your water tested, knowing how to address it, having that water management team in place. The water management team already knows the facilities. They already have infection control. They already have the risk team in place. Adding the SPD manager, supervisor, adding the biomed people that are tied to the maintenance, repair, and operation of the equipment, all very valuable contributors to avoiding that in the first place.
You know, you're absolutely right. If you see it happening, it's already happened. And what I have noticed in the past is you see it on this set of instruments, but how many other instruments have gone through and gotten by that somebody didn't notice? And unfortunately, sometimes it's being wiped off, whatever's being seen. The tech says, oh, we don't have time to redo this because Dr. So-and-so really needs it. So we'll just wipe off this whatever I see and get it to him. And that's not the right answer. We need to empower our technicians to speak up when they see something wrong, even if they don't know what it is. It is, if there's something on the instrument, it's not okay. It should be coming out clean, not with a stain or calcification spots or anything else. So I'm glad that you brought that up. Jeff, do you have anything to add here? Things we should be looking for, or things that should cause alarm?
Well, yeah. I mean, water quality problems are generally going to show up as visual problems, and they're generally going to show up when they're inspecting the instruments, and it's going to be discoloration, staining, white spots, other colored spots, rainbow type effects are all good indications you may have a water problem, or there could be some other issue going on with maybe your detergents or something like that. But
yeah, you're absolutely right. It may not be water. It could be something else, but it's a good indicator that something's not going right. So we all need to pause and figure it out. We have actually reached the end of our session here. So we're going to start to wrap up. And what I like to ask everyone to do is to give one kind of tidbit, go and do tip that everybody listening can take and put into place easily, get started. I know ST108 seems very daunting and overwhelming at first. So I want everybody to just give one kind of tip to everybody listening on what they can go and do right now to get started or to enhance their water quality system. And Shane, I'll start with you.
Read ST108 or bring in a consultant that knows ST108. Know the shalls and the shoulds, because when you do have your next inspection, whether it's Joint Commission or DMV, know what their expectations are and be able to answer those. You're not going to conquer this in a day, but lean on your water management team to assist in water quality issues that you may be less comfortable with. So this will evolve. TIR evolved into ST108, ASHRAE 188 evolved into ASHRAE 514, and just know there are a lot of resources out there. Jill, Aaron, Jeffrey are all fabulous resources. So thank you very much for this opportunity.
I'm glad you mentioned how the AAMI standards read. There are many of us who have worked on these AAMI standards committees for years who really know how to read and interpret these standards. And that's why it's important to reach out to somebody, get a consultant in, like Shane mentioned, because just understanding how to read some of these standards and understanding how the regulatory agencies are going to ask about them, because the AAMI standards are consensus documents. But if you write it into your policy that you follow ST108, you're tied to it. So you have to be careful how you write your policies. You have to understand how to read the standards. And that's what some of us can absolutely help you understand. Jeff, you're up.
One of the first barriers I see is that with departments getting started is that water quality in the SPD is everybody and nobody's responsibility. SPD may have to be responsible for it, but they have no tools to fix it, implement anything, or the expertise to really understand root causes or anything else. Your facilities people probably understand a lot more about water quality and piping design and whatnot, can, I think, offer a lot of support in helping you do a risk assessment and understanding a little bit more about water quality. So I think really kind of befriending your facilities engineering and maybe your biomed department and getting them bought into the idea that both economically and from a safety point that we all need to do this. And by doing good things here, we're going to do good things for the patients and for our team.
I'm really glad that you mentioned the team. The team is the first thing that ST108 talks about. And a lot of people have a water management team already in their facility. But when you talk about the ST108 team, it's a little bit different. So you're going to have to decide in your facility, do I want to make it part of my regular water management plan team, or do I want to have a kind of sub team that includes just people working specifically on SPD, which is my preference. And then do I want to have a water management plan that's specific to SPD, that is maybe an appendix or an addendum to the hospital water management plan? Because as Shane alluded to, the water management plan for a facility is really geared towards Legionella. SPD water management plans are completely different. So you really have to make that decision first, but then gather that team together. And it may look a little different, but very similar to your facility water management team. All right, Aaron, take us home.
Yeah, this are really some great points that Shane and Jeffrey brought up. To kind of surmise it, I'd say, I think we want to go out. You want to meet your SPD, meet your facilities, introduce them to each other if they have not had introductions, and then start figuring out where water is traveling. That group of people will help you. They'll tell you what it's being used on. And my facility I've been at for over 7 years, and we are still discovering new ways water is moving around the building. And so I think there's always something new. It's an evolving document. I think SE 108 and also the standard 514 that Shane mentioned says that it needs to be evolving. You need to work with it evolving, but it talks about getting people together, going through, being in the space, discovering what you need to discover and how you're going to use it, and then eventually put out the best quality water for our patients so that we can do an awesome job for them.
Great. Thank you guys so much for being here today. This was a great episode. I think we could have talked for a couple more hours about water quality. There was so much still to learn, but we are out of time for today. So that does it for episode 4. Thanks so much, everybody, for being here.
Thank you very much.
Thanks. Episode. A lot of things I got out about team building, getting those good connections and people put together from your facilities and sterile processing department, and also focus on filtration and some of the different types of filtration that can affect the sterile processing department. There's some really great information here.
Yeah, I think ST 108 can be really overwhelming to some people, whether you're in IP, facilities, OR, SPD. It can seem like a lot when you're first reading the standard or trying to implement it. So once you listen to this episode and once you read the standard, just know there are people that can help you understand it, and just go slow. Take it bit by bit. You can't implement the entire standard all at once, but you can do piece by piece and slowly improve your water quality and patient safety. Thanks for listening to episode 4. Keep fighting dirty, and don't forget to wash your hands.
Thanks for tuning in to this exclusive podcast series on pathogens and PPE. For more information and clinical resources to help you fight dirty, make sure to follow us on social media by searching for Beyond Clean and Transmission Control.